Hello, this is first video on design of RCC slabs by limit state method, and first we are looking at some theoretical background. Now first of all, when it comes to RCC slab, understand this classification. There are one-way slabs and two-way slabs. Because you have done earlier course on precious concrete, you know what they are. Then the new thing is flat slab, supported directly on columns without beams. All the parking lots, have this kind of slabs, flat slabs, because depth of beam will then hamper the height of the vehicles. Then there is grid slab, which you see in theaters. You see, theaters you don't want any column obstruction, so there is a grid slab, that is one beam supports the other beam. Analysis is complicated in that, but that's example of grid slab. Then for water tanks and all, there are circular slab and there are slabs of other shapes. For this course, you need to do only with one-way and two-way slabs. So, just to refresh your memories, it is the Ly by Lx ratio. If it is greater than or equal to 2, it's one way. If it's less, two way. And remember one thing, Ly and Lx have nothing to do with x and y axis. It is larger upon small. Now let's talk about design consideration for one-way slab, and I think same holds for two-way slab also. Now effective span, what will you take span? For simply supported slabs, the effective span is equal to clear span plus effective depth, or center to center of support, whichever is less. Then slabs are usually not designed as doubly reinforced, so that's easy for us, except for some special cases which we will not deal with. The reinforcement reinforcement perpendicular to the main reinforcement is known as distribution steel, which is placed in the second layer always. Main is on the bottom layer. And for reinforcement, minimum reinforcement, as you see, 0.15% for mild steel, 0.12% for high strength steel. And where B is the width, we are going to take 1000 in this case. Maximum diameter of the bar in the slab should not exceed 1/8 of the total thickness of slab. Okay, so we can't have larger diameters bars in a thinner slab. Then minimum diameter for main bars, if it is plain it is 10 mm, and if it is tall it is 8 mm, and for distribution bars minimum diameter is 6 mm in any case. Distribution steel is only for tying, you see. So no design requirement is there. So they said that at least you should have 6 mm. These are all coded requirements. Now, good part is we don't even design shear reinforcement in the slab. So we make sure that the slab thickness, is good enough. And here you are allowed to modify the tau c by these factors. If slab is less than 150, you can multiply tau c by 1.3. If it is between 150 and 300, you can use this formula, and if it is more than 300, then there is the factor is only 1. Deflection shall be checked same manner as the beams. But here usually now we apply modification factor using this chart, which will be provided to you in the examination. On the y-axis of this chart, there is a modification factor by which you can apply apply the ratio. This will be let's say for simply supported beams, span to depth ratio is 20. But then suppose you get modification factor 1.2, then it will be 20 into 1.2, that is 24. And on the x-axis, there is Fs, and Fs is given by this formula, which is 0.58 Fy multiplied by area of cross section of steel required and area of cross section of steel provided. See, you require something, you provide slightly more. So this is all established in the code, and you are expected to follow it. Yes, of course you need it. If you find that slab depth is not satisfying, that span to depth ratio is 20 for simply supported, then check with this. All these points will be clear moment we look at problem. Then cracking. For cracking requirement, all you have to take care is spacing is not too much. And what is too much? Uh, no spacing of main bar shall exceed 300 or 3 times effective depth. Okay, whichever is smaller. And for secondary bars, that is distribution bars, the numbers are 5D and 450. Then cover. For mild exposure, you use clear cover as 15, which will be using more often, and for 15 for up to bars which are less than 20 mm dia, and 20 if bars are more than 20 mm dia. Development length in the slab shall be checked in exactly same manner as beam, and that's all the theoretical background you need. Thank you.